Yesterday we talked about how when we were given a standard form of a quadratic, we can use the method of completing the square to turn it into the vertex form of the quadratic, because it's nice to have both the standard form and the vertex form when solving for the turning points and things like that. But another thing we need to remember during last unit is when we need to complete the square, we need to have, or the complete the square works best when a is 1 and then the b is an even number. And so when a isn't 1, the thing we had to do last unit was we had to divide everything by that leading coefficient of a. So we'd have to divide everything by whatever that number was. And so in order to use completing the square for turning a standard form quadratic into a vertex form quadratic, we also have to make sure that leading coefficient is 1, and we'll have to factor out that a and divide if it isn't. But today should be really similar to yesterday, so if you understood yesterday, then I think you guys would do fine today. And so we're going to place each of our standard form quadratics that we were given into a vertex form, and then we're going to find the turning point, like we do, and then we'll graph them at the same time, and we'll see if they overlap, and if they do, that means we did it right. And so the first step of completing the square, if you guys can't remember, you might want to pull out your notes from yesterday and get them next to you so you can look back and forth if you have trouble remembering the steps. But what do you think the first step of completing the square should be? Jordan?
C to the other side.
So we want to get all our variables on one side, so all our x's on one side and all our y and our constants on the other. So we're going to subtract c to both sides to get it to the other side. So we have y minus 16 equals 2x squared plus 8x. And now here's the new step that we're adding in today. We need to remember that our a, or our first coefficient, our leading coefficient, has to be 1. So in order to turn it into 1, we're going to divide the whole thing by that leading coefficient. So in this case, it's 2, so we're going to divide the whole problem by 2. And so we have y over 2 minus 16 over 2. So what is 16 divided by 2? 8. So we'll have y minus 8, and this equals 2 divided by 2 is 1, and that's the leading coefficient that we wanted. So we're going to have x squared, and then what is 8 divided by 2? 4. So we have 4x. And so now we have to remember our next step in completing the square, where we have to, or what do we have to do next? Oscar. So we can add b over 2a, or b over 2 squared to both sides. And so what is our b in this case? 4. So we're going to add 4 over 2 squared to both sides. And we have to remember that it has to be both sides to make sure they're still equal. And so we have y over 2 minus 8. And then what is 4 divided by 2? What would that give us? 2. And then what is 2 squared, Tiffany? 4. So we're going to add 4. And then we have x squared plus 4x. And it's the same thing. 4 over 2 is 2. 2 squared is 4. And now we can clean this up a little bit, and we can add our constants together on our left side. So we have y over 2, and then negative 8 plus 4. What will that give us? Jordan? Negative 4. And then we have our perfect square trinomial on our right side. So if you remember, the perfect square trinomial is going to factor into two same factors. So they're both going to look the same. And if we remember our little trick, we can just drop x down, and then we can look up to see what we added to both sides. The inside of that was 4 over 2, and we can take that number, and that would be our second number. So 4 over 2 was 2, And so we'll add x plus 2 and x plus 2. Back this up a little bit. So now we have y over 2 minus 4 equals x plus 2 times x plus 2. And x plus 2 times x plus 2 are the same, so we can compress them together. So we have y over 2 minus 4 equals x plus 2 squared. Oh, I think I double tapped that. So now that we have our x plus 2 squared, we need to solve for y to get it into our vertex form. So what should be our first step to get y by itself? So add 4. So we add 4 to get our 4 to the right side. So we have y over 2 equals x plus 2 squared plus 4. And now we have one final step to get y by itself. Bradley? We can multiply both sides by 2. Ooh. And so we have y equals 2 times x plus 2 squared. But then we're multiplying the whole thing by 2. So this is 2 times x plus 2 squared, and then 2 times 4. So what's 2 times 4 going to give us? 8. So plus 8. So our vertex form of our equation is y equals 2 times x plus 2 squared plus 8. And now, if you remember, the reason we want our vertex form... Oh, that's not what I wanted. So the reason we want our vertex form is because we can find the turning point or the vertex very easily from our vertex form. So what is our turning point going to be for this quadratic? Jordan? -2, 8. And so if we remember, our turning point is hk, and the vertex form of our equation is y equals a x minus h squared plus k. And so we look at our h from our equation, and we see we have the negative in front of it, so we need to flip the sign of our h from our equation. So we have 2, so we need to take a -2, and then we have k, and it's plus k, so we keep the same sign for k, so we have positive 8. So -2, positive 8. And another way to check to see if this equation, our new vertex form of our quadratic, and our standard form of our quadratic is the same, is if we graph them. So we're going to pull up our graphing calculator, and then we're going to input both of them at the same time. So our first one that we started with, the standard form, was 2x squared. That's not what I want. I'm sorry, guys. 2x squared plus 8x plus 16. And then the new vertex form that we just ended up with was y equals 2 x plus 2, and then the whole thing squared plus 8. Now we're going to graph. And so there's our first graph, and there's the second one. And because we see that the lines went over each other and cross each other, and so our blue line is over top our red line, or our red line is over the blue one, whatever the colors are, then we know that both the quadratics are the same, and so we know we got the right answer when changing our standard form to vertex form. Pause it. That was 2. Are you guys staying with me? Thumbs up, thumbs down? I don't know if I actually did anything. Okay.
Check with the red again. Oh, we never paused it.
Okay. And so let's look at this next one. And so, just like in our last complete the square problems, what should be the first step we want to take to complete the square? Tiffany? So first thing we can do is move over the negative 1. So we're going to add 1 to both sides. And so we have y plus 1 equals negative x squared plus 6x. And now, what is the new step that we added in today that we didn't do yesterday that we need to remember when completing the square? Jordan?
You need to divide the number in front of the x squared.
So we need to divide by our leading coefficient. And right now, we don't really have a number in there. We just have the negative. But if we remember, when we don't have a number, we have that hidden 1. So there's really just a hidden 1 in front of this negative. And so it's actually, we're going to divide everything by negative 1. And so we have y divided by negative 1. But y divided by negative 1, that's just the same as negative y, correct? And so I'm just going to turn this into negative y. And then what is 1 divided by negative 1? Negative 1. And then we have negative 1 divided by negative 1, which gives us 1. That's our leading coefficient that we want to when we have when we complete the square. And then lastly, what's 6 divided by negative 1? Tiffany? Negative 6. We have negative 6x. And so now, our next step during completing the square, what should we do? Jordan?
B divided by 2 squared.
So we want to add b over 2 squared to both sides. And what is our b for this quadratic? Negative 6. Exactly. So we have negative 6 over 2 squared and negative 6 over 2 squared. And so we have negative y minus 1 plus, what is negative 6 divided by 2? Negative 3. Good job, Isaac. And then what is negative 3 squared? Tiffany? Almost, it's positive 9 because it's negative 3 times a negative 3, which gives us a positive 9. And then we have x squared minus 6x. And because we added the same thing to both sides, we'll add a positive 9 on this side. And now we can clean up our left side. We have negative y and then negative 1 plus 9. What is negative 1 plus 9? 8. So we have plus 8, and this equals our perfect square trinomial. So our perfect square trinomial is going to break down into the two same factors. So they're both going to look the same. If we remember, we can drop down x, and we can look up to see what we added to both sides, and we can take what's on the inside. So negative 6 divided by 2 is negative 3. So we have x minus 3 and x minus 3. And so, because x minus 3 and x minus 3 are the same, once again we can compress them together. And we have y plus 8 equals x minus 3 squared. And now that we have our x minus 3 squared, we need to get y by itself. So what should be the first step to get y by itself? Oscar? So we could divide. That could be one possible way, but what I would probably prefer to do, and would probably end up to be a little bit easier, is to subtract 8. So I'll subtract 8 to get 8 on the other side. And so we have negative y equals x minus 3 squared minus 8. And now, Oscar, what should we do? divide. And so we're going to divide by what's in front of our y, which in this case is -1. So we're going to divide everything by -1 again. And so negative y minus, or divided by y, is just going to give us, or divided by 1, I'm sorry, is going to give us y. And then we have we have x minus 3 squared divided by -1. And when we divide by -1, our number stays the same, but we change our sign. Because anytime we divide by 1, our number stays the same. But because it's -1, we're flipping our sign. So we're going to have negative x minus 3 squared. And then what is -8 divided by -1? Positive 8. So we'll add 8. And so, Oscar, you could have divided first and then subtracted the 8 over to the other side, and you still would have gotten the same answer, but we tend to work, you would have to factor out the -1 first, but it still would have given you the same answer. And so this is our new quadratic, and this is the vertex form of our quadratic, but it's the same one that we started with. And so we want to find the turning point, because that's why we like to have the vertex form, so we can find the turning point or the vertex of the quadratic. So what is the turning point of this quadratic going to be? Ordered pair. Jordan, do you know? 3 positive 8. So if we remember, just like on the last one, we look at our h, which is right here in our vertex, and we take the opposite sign of that h. So it's a -3, so we're going to have a +3 for our turning point. And then we take our k, which is at the end of the vertex form, and then we keep the same sign because it's plus k, so we have a 3, 8 as our turning point. So we're going to work through one more example, and then we'll let you guys try your hand at the practice. And I think you all seem to have this down fairly well. It's really simple, or it's really similar to what we did yesterday. So if you understood that, then I think you guys are golden for today. And so last time, what should be the first step that we need to take when completing the square? Add c to the other side. So c for this one is 21. So we're going to add 21. So we have y plus 21 equals 5x squared minus 10x. Now, we need our leading coefficient to be 1. So how are we going to get our leading coefficient to be 1? Yes, Tiffany? We can divide everything by 5. Because our leading coefficient is 5. And so we have y over 5 plus 21 over 5, which 21 over 5 doesn't reduce, it would turn into a decimal, but we like to keep fractions for now, so we're just going to leave it as 21 over 5 for the moment. And then this is equal to 5 divided by 5x, or 5. So 5 divided by 5 is going to be 1, so we'll get our leading coefficient of 1, which is what we wanted, so that's why we divided by 5. And then we have -10 divided by 5. What will that give us? Okay, Kayla? Good job. So we have -2x. And so now we need to take the next step for completing the square. So Isaac, what do you think the next step for completing the square is?
You would add -2 over 2 squared.
Yeah, so we're going to add our b over 2 squared to both sides. So in this case, it's -2 over 2 squared. We add it to both sides. So on the left side, we have y over 5 plus 21 over 5 plus, what is negative 2 divided by 2? Jordan? Negative 1, and then what is negative 1 squared? 1, because it's negative 1 times negative 1, which gives us positive 1. Extend the page a little bit. And so on this side we have x squared minus 2x, and then we added 1 to this side, and because we added the same thing to both sides, we'll get a plus 1 on our right side. And so we can clean up our left side a little bit. And so we have y over 5, but then we have 21 over 5 and 1 over 5. In order to add these two together, we need a common denominator. And so we have 21 over 5, but 1 is the same as 1 over 1. And so how would we find a common denominator between 5 and 1? Grab it. So it's 5, and we get 5 by multiplying 5 and 1 together. So if we multiply 5 by 1, we get 5. And so we have y over 5 plus 21 over 5. And we got the 5 as our common denominator by multiplying it. But if we multiply the denominator by 5, we have to multiply the numerator by 5 to keep it the same number. So we have 5 over 5, which should be the same as 1, like we started with. And now we can add these two together. And I'm going to write our right side over just to remember that it's there as well. And so what is 21 plus 5? Tiffany? 26. So we have y over 5 plus 26 over 5. And this is equal to our right side. And if we look, our right side is another perfect square trinomial. So our perfect square trinomial is what we can factor into the two same factors. So what do you think these factors are going to be? Negative 1. So we have x minus 1 and x minus 1. And so if we remember to do that, we take our x down and then we look up, way back up here, to what we added to both sides, which was negative 2 over 2 squared, and we can take the inside. And so negative 2 over 2 is negative 1. So we have x minus 1 times x minus 1 as our factors. And now we have y over 5 plus 26 over 5, and this is equal to x minus 1 times x minus 1, which is the same, so we can compress that together. And we have x minus 1 squared. So now we need to get it into the last shape of our vertex form, and so we need to solve for y and get y by itself. So what should be our first step to get y by itself?
26 over.
We can subtract 26 over 5 to get the 26 over 5 to both sides. And so we have y over 5 equals x minus 1 squared minus 26 over 5. And now our last step to get y by itself. Tiffany?
Multiply 5 on both sides.
So we can multiply everything by 5. And so 5 times 5 cancel, or 5 on the top and 5 on the bottom cancel out. So we have y, and then we have 5 times x minus 1 squared. But we have to remember everything on our right side has to be multiplied by 5. So we also have 5 times negative 26 over 5. And because it's already being divided by 5 and we're multiplying it by 5, those also will cancel out, and we'll be left with negative 26. So now we have our vertex form of our equation once again. And what is our turning point for our vertex? going to be for this quadratic? Emily? 1, negative 26. So if we remember, we take our h, which is the 1, and then we flip the sign, so it's negative 1, so we get positive 1. Oh, I'm sorry, I wrote negative 1 here. So we get positive 1, and then we take our k, which is negative 26, and we keep that sign because it's a plus k, and so it's negative 26. And now lastly, to check to see if we got the right answer, we're going to pull out our graphing calculator, and we're going to plug both equations in and graph them at the same time. So our first one is 5x 5x squared minus 10x minus 21. And then our second is 5 quantity x minus 1 squared minus 26. Sorry. Minus 26. Nope. I'm just going to try this again. 2. There we go. And then we're going to graph them at the same time. And because we see that both graphs cover the same quadratic and they both fall on top of each other, we know our answers were the same.